In this video, I'll talk about the continuity of a function. The name itself gives us the idea that the curve of the function should be continuous. That is, if I try to draw the graph and if I'm able to draw the curve without picking up the pen in some particular domain, then that function will be continuous. That is, there are no holes, breaks or jump in this curve. Now what are holes, breaks or jumps? So let's take more examples. Let's say we are given a curve which is not defined at the point A and it looks like this. Now this is a hole at the point A. That means the function is not defined at this point. So there is a little hole over here. Or if I take some curve where the function is defined at this point, let's say this is f of A. That means this function is defined at point A. But still the graph of this function looks something like this. That means there is a jump in this curve. This is not a continuous curve. Or the curve can look like this, where this point is again at this point the function is not defined. So this is a break in the curve. So all these are the examples of the functions which are not continuous at the point A. Now let's see the formal definition of continuity. A function f of x is continuous at the point A if there are two conditions. First of all, f of A must be defined. That is, at this point where we have to check the continuity, the function should be defined. That means when I plug this point into the function, I should get a defined value. So the first condition is f of A must be defined. And the second condition is limit of the given function f of x at this point. That is when x is approaching to A, must exist, and the value of this limit must be equal to f of A. If it will exist, if this limit exists, then there must be a value and that value must be equal to f of A. If these two conditions hold, then the given function is continuous at some given point A. Now let's see why these functions are not continuous according to this definition. So in this case, at the point A, the function is not defined. So what does the first condition say? The function must be defined. Now in this case, this function is not defined at A, but the limit exists in this case. That is, when x is approaching to A from the left side, the function is approaching to this value. Let's say this value is L. And when x is approaching to A from the right side, the function is approaching to the value L. That means the limit is existing, but because f of A is not defined, so this function is not continuous. Now in this case, we see that the function is defined at the point A. This is the point A and this is f of A. But here the limit is not existing, as when x is approaching to A from the left side, this function is approaching to, let's say this point is L1, and when x is approaching to A from the right side, this function is approaching to f of A. So the limit is not existing. So that means this function is not continuous by this definition. In this case also, at point A, f of A is not defined. So the first condition is not holding and the second condition is also not holding, as when x is approaching to A from the left side, the function is approaching to positive infinity. When x is approaching to A from the right side, the function is approaching to negative infinity. So in this case, both the conditions are not true. So that means this function is also not continuous by this definition. Now I will draw a graph where a function is continuous. Let's say this is x-axis, y-axis at a point A. Now this is the point A, and let's say this is the point f of A, and this is the function f of x. Now if I see it graphically, this curve is continuous, but let's see by definition. Now here at the point A, f of A is defined and the limit is also existing here, as when x is approaching to A from the left, the function is approaching to this point which is f of A, and from the right, when x is approaching to A, the function is approaching to again f of A from the right side. That means the limit is existing and is equal to f of A. That means this function is continuous. So now you see what is the relation between the graph and the formal definition of the continuity.